So we have, this lesson is 4.8. It's in the textbook, 4.8. It is in Unit 5. It's our Unit 5. And it's all about the basic counting rule and combinations. So we often need to determine the number of ways something can happen. So sometimes listing all the possible outcomes is inconvenient. We only had 4 letters to choose from, and we didn't even finish that one, listing out all the possible outcomes. So it just takes a long time, right? So our first way to determine the number of possible outcomes is just the basic counting rule. We sometimes abbreviate that BCR. So here's another license plate question. Read for me, please, Allie.
The license plates of the state consist of 3 letters followed by 3 digits. How many different license plates are possible?
Thanks. So 3 letters followed by 3 digits. There are no exclusions in this question, so we've got 26 times 26 times 26, and then the 3 digits, so we have 10 times 10 times 10. And you multiply those all together in your calculator, and what do you get?
17,576,000.
So you get 17,576,000. Thank you. And we just ran into this little box. It says, what does it mean the total number of ways that several actions can occur equals the product of the individual number of ways for each action? So that's just explaining the process we just went through. How many possibilities then are there for a license plate on which no letter or digit is repeated? So same setup, right? We have 3 letters followed by 3 digits, and we have 26 letters to choose from to start. But once we fill that first spot, how many letters do we have to choose from? 25. And then 24. Similarly, 10 digits to choose from for that first spot. But then once we put a digit in that first spot, we only have 9 left to choose from. And then 8. Thanks. Does anybody else get the same number? Great. Nice job. So this is a quick and easy way to do the basic counting rule. Sometimes it's important to have all possible outcomes actually listed out. So there's a scenario here. Do you want to read that for us, please, Tyler?
Sure. Home models and elevations. Robson Communities Incorporated builds new home communities in southern parts of the western United States. In one subdivision, it offers 4 models: the Shalimar, the Palacia, the Valencia, and Monterey Jack cheese. Each in 3 different elevations, designated A, B, and C. How many choices are there for the selection of each home, including both model and elevation?
Okay, so we've got 2 things going on here. We have the different models. Nice job. Different models and the different levels. So a pretty standard way to list all possible outcomes and kind of keep track of things is using a tree diagram. So I'm just going to use a capital letter to represent each of the models. S, P, V, and M. And you might see that labeled. So this would be the models. And then we're going to talk about the elevations in this column here. So coming off of each of my models are 3 elevations. And then lastly, I list the outcomes, all the possible outcomes. And having it listed this way just makes it really easy to observe. So SA is one outcome, SB, and SC. Obviously this is a very simple example, so you probably list these out without a tree diagram, but it goes to help demonstrate in more complicated situations what you could also do. So then we have PA, PB, and PC, VA, VB, and VC. And MA. And so then the question is, how many choices are there? And so we could count these all up. We could have also done the counting rule 4 times 3, so we have 12 possibilities. All right, so next we have the factorial. Many of you know Hamilton is famous for having the factorial at the end of its name. It was, does anybody know about that? As an actual city listed on, when you were addressing an envelope, it was standard for a period of time to put an exclamation point at the end of Hamilton. Hamilton. So anyway, it's totally unrelated, but factorials are, has anybody heard of factorials? Okay, a couple of you, a few of you. Just means take a number and multiply it by every number leading up to it. So, for example, when I have a 5 exclamation point, it means to multiply 5 times 4 times 3 times 2 times 1. It's a lot easier to write 5 factorial, right? And then, so it's 120. So go ahead and find for me 7 factorial. Right, and that would be 7 times 6 times 5 times 4 times 3 times 2 times 1. What'd you get, Cheyenne?
5,040.
Anybody else? 5, thank you. 5,040. Did anybody do it the shortcut way where you already knew that 5 times 4 times 3 times 2 times 1 was 120? Multiply that times 7 times 6? No? Okay. Just curious. So either way, it's 5,040. The next one I want you to do is 12 factorial. Fastest wins. Go. Andrew had his hand up first. What did you get? Fine. Tyler, go ahead.
I got 479,001,000.
Okay, so he said 479 million 1,000 1,600. Oh man. So just like this, right? Everybody use just like theirs look like that. Yeah. Any difference between what I did and you did?
Yeah. Where is it?
Emma's giving away all the secrets.
Yes.
It's in the math menu. So go ahead and try that again using the factorial button in your graphing calculator. lovely day.
I don't see it.
Me neither.
Am I stupid?
Max. So type in 12. And then go over 2 or 3 to probably
Hello. Zach didn't hear you the first time. Can you repeat it?
Oh, okay, you click the math button, and then you go over to where it says PRV, and then you go down. She didn't explain it.
Great. Thanks. So now you found it. Hopefully you caught on to that. So we now have a quick way to find factorials. That's good. Next up, we're going to talk about permutations, and you're going to see in this formula, this fancy formula we'll take a look at in a second, there are factorials involved. But first, let's start at the beginning. So a permutation of R objects. So noting what the variables mean is super important, right? R is the number of objects from a collection of M objects. Which one of those would be larger? The number of objects or the number that you want in your collection?
Yes.
So the total number of objects to choose from would be the larger one, right? So, and is any ordered arrangement I'd put a star by that. What do we put a star by, Ben?
Ordered.
Okay, and that's important. Zach, did you get that?
No, I was trying to figure out what that said.
Ordered arrangement.
No, the word. Okay.
So the number of possible permutations of R objects that can be formed from a collection of M objects is denoted MPR. Please cross that out. Let's write it correctly. It has subscripts. The M is a subscript and the R is a subscript. So it should be read M permute R. This is how you read that. And it's important to read it correctly. So if I call on you, please read it correctly. Arrangement of letters. So we're taking a look at 5 letters, A, B, C, D, E, and listing all the possible permutations. And that's actually already done for you. You're welcome. So I didn't make you list all of those out. It's done for you. Part A is answered. So I could list ABC, ACB, BAC, BCA, CAB, CBA. Same 3 letters, but 6 different ways to arrange them, similar to what we did in our opener. How many total, then, this question B is asking, possible permutations are there for the 3 letters that can be formed? 60, good. So if you just add all these up or multiply 10 columns times 6 rows, get 60. That doesn't even hardly look like a 60. So 60. And then there you see the abbreviation. Use the basic counting rule to determine the number of possible permutations of 3 letters that can be formed from the collection of 5 letters. That is, find 5 permute 3 by using DCR. So basic counting rule. The standard is to write blanks indicating the different spots and then fill those in with the number of possibilities. So in the first spot, how many different letters do you have to choose from?
Wait.
5?
Oh, it's,
And then how many do you have to choose from for the second spot? 4. We don't have any repeats. And 3. So 5 times 4 times 3, and 5 times 4 is 20, times 3 is 60. So there are 60, again, same answer. And then we have the permutation rule, where it says the number of possible objects, or permutations of R objects. Again, it's defining what R is. Collection of M, the collection, the larger group that you're choosing from. Sometimes they're equal. Sometimes you've got 4 letters to fill and 4 to choose from. But R would never be larger than M. Those are the common mistakes I see people make when starting this off. So in our example, we would write that as 5 permute 3. And applying this formula, we would write 5 factorial over 5 minus 3 factorial. Or 5 factorial over 2 factorial. So 5 factorial means, and we're going to write this out, 5 times 4 times 3 times 2 times 1 over 2 times 1. It's time. And if you think about reducing fractions by common factors, we could do the 2 times 1 and the 2 times 1 and cancel those out. And what are we left with? 5 times 4 times 3. Same thing as we started with in the basic counting rule, which we know to be 60. I do want you to practice using your calculator. So how you would do this one, a lot of times you just subtract that first. There's no reason to overcomplicate what you're entering in your calculator. 5 minus 3 is a simple subtraction. So I'm going to do 5, and then I'm going to hit my math key. We're doing this example together. Prob, and then 4, which gives me the factorial. And then divided by 2. What's 2 times 1? 2. For the sake of practice, I'm going to actually enter in the factorial button again, even though all I need is the 2 there. So I need to see you doing this with me. So everyone should have their own graphing calculator. And we get 60. Practicing it will make it more familiar and then lead to more success. So we have 60 ways. There's another way. Did you see it?
Yep.
Now there's different types of calculators. I'll show you first using this type of calculator. If your calculator says TI-84 plus C, then you can do it this way. Okay? If it doesn't say TI-84 plus C, then you'll need to do it a different way. But I can actually go to the probability menu and choose the permutation key and enter in my M, or in this case they use the letter N. They're interchangeable. They mean the same thing. Sorry. So 5 permute 3, and again I get the same answer. If you have an older calculator, the TI-83 plus, or even the TI-84 plus that's not the C edition, then you still have the probability, same spot 2. The only problem is it says answer. It doesn't have those subscript possibilities. So the way to do that is actually to first enter in your N value or M value, then go over and select your permutation, and then enter the number of objects. It's not too complicated. And there you go. So it works on both. Exacta wagering. Anybody been to the horse races before? No? Okay. So exacta wagering, there's all these different names for types of bets you can place in horse racing. And exacta wagering is when the bettor picks the 2 horses that he or she thinks will finish first and second in a specified order. See that word? Specified order? Those are the key terms you're looking for to determine, am I looking at a permutation or not? Order matters. So there's 12 entrants. There's 12 different horses in this race, and I want to be able to determine the number of different ways I could wager this bet. Okay? So I could list them out using my basic counting rule. I'm not listing them out, sorry. I'm just using my basic counting rule here. So there are 12 different options I have for that. For first place, and then 11 options for second place. So I could just do 12 times 11. So what do you get when you do 12 times 11? 132. Yep, so you didn't even need your calculator for that. And then to do it using my permutation, 12 permute 11. I have 12 to choose from. I'm arranging, or sorry, how many am I arranging? 2. I only have 2 places, first and second. So 12 permute 2. So I want to first write that out using the formula 12 factorial over 12 minus 2 factorial. So 12 factorial over 10 factorial. And again, we get 132. I will say on your test, you'll need to be able to recognize that this is the formula. This is the formula for a permutation. You get to use your notes, so make sure you're just careful. That's all you don't have to memorize it, but these are useful formulas if you're taking the ACT, things like that. You would have to memorize them. And next, we have arranging books on a shelf. So a student has 10 books to arrange on a bookshelf. What's my N value? Or my M? How many am I choosing from? 10. How many am I placing? 10. You're placing all 10 on the shelf, right? So this time I'm doing 10 permute 10. That's the only, the closest you can get is having them equal. R will never be greater than M, in other words. And so the way that we would do that is 10 factorial over, I subtract these two, right? 10 minus 10 factorial. That's in parentheses. So 10 minus 10, that's 0. Can this be done? We have a 0 in the denominator. Did you already know that?
Yeah, it was in the thing.
So 0 factorial, it was in the definition. Yeah. Good observation. 0 factorial is 1. So you want to keep that in mind. You're just, anytime you see a 0 factorial, 1. So you have 10 factorial. So all you really need to do for this one is enter into your calculator 10 factorial. Go ahead. I'm waiting on you. Enter 10 factorial in your calculator, please. What'd you get? Zach Butler, what'd you get?
36,288,0.
36288. How many zeros are there?
2 zeros.
Thanks. So then I'll throw in my comment, and then I'll be able to read it. 3,628,800. Is that what anyone else got? Great. Nice job. Next. This is it, guys. Combinations. So weird, but just got to point out, when you're trying to figure out a lock such as this, is it a permutation? Does order matter? Does it matter if I enter a 7 and then?
Yes.
And yeah, order matters. This is actually called a permutation on a lock, right? So arranging these, order matters, okay? But now we're going to talk about combinations. All right? Combinations are where order does not matter. Okay? We call those unordered arrangements. And we want to go back to that same example, 5 letters, 3 to choose. And you can see ABC, there's only ABC listed. In the previous example, we have ABC in 6 different ways, right? So we're covered just by listing those 3. Doesn't matter the order. And this A, B, D, A, B, all those. So how many then possible combinations are there? Just count them all up, and what do we get? 10. Will you read the next one for us, please, Zach Ethan?
B.
Note. We just answered B.
Look back at the first combination in table 415. By the special permutations rule, there are 3 factorial equals 6 permutations of these 3 letters among themselves. They're hidden. All those. Because any such permutation is accounted for in this way, there must be 3 factorial times as many permutations as combinations.
There must be 3 times as many permutations as combinations. Good.
Oh, the whole isn't being a word, so it's combinations. Wait, why'd you tell me I was wrong?
Just repeating it.
No, Ben
So-
said it wasn't combinations.
Since there are 3 factorial times as many permutations as combinations, it would make sense in the combinations formula to divide that out. So you can see that in this formula. It's the same formula as permutations with the R factorial divided out. Okay, R and M mean the same thing. Order does not matter in combination. So let's look at an example, CD Club introductory offer. So there were these things back in the day called CD clubs. I was a member of 2 of them. The Columbia and the BMG music CD clubs. And what you do is you get this little booklet in the mail. It was so exciting, getting mail is exciting. So you're like, it had all these different CDs to choose from, the latest and greatest, so all different kinds. And they had, some of them had little stickers, which was cool, and they had little spots, and you could choose, say, 13 CDs for free if you just buy one. Okay, it was the greatest thing. So you fill out this form, you send it away, arrives in a box, 14 CDs, right? You paid like $14 for one CD. The only catch was now you were signed up for the membership. And so every month you got a CD that you had to pay full price for, unless you canceled it, which was, I forgot to cancel it all the time. So I signed up multiple times, like, I'm going to do it, I want these free CDs, and then I wind up, paying for all these CDs I didn't want because they just sent you the CD of the month. So that's what this is talking about. Some people were really clever. They would get the CD offer and sign up and cancel it in time, but they would sign up under like alias names and get they were members, they were like 12 times over members of the CD club, but they were scammers. Okay, anyway, to recruit new, parents hated these things. My parents hated when these things were read, like, don't do it. But we just got sucked in every time. And so they would offer, a special offer to start the club. You get 1 CD at pay for 1, regular price, you get 4 for free. And there were total 69 CDs to choose from. So how many possibilities does a new member have? Well, it didn't matter if you got like the Fugees and the Cranberries and Bob Marley and No Doubt, or it didn't matter the order of your CDs. Those are ones I got those. It just mattered that they were in there. So this would be a combination of total of how many? 5? You got 4 free and paid for 1. So 5 choose is how we read this. 5 choose. Nope. Sorry. It's 69. Choose 5. 69. Choose 5. I have 69 to choose from, and I want 5. So I'd write that as 69 factorial over 5 factorial times 69 minus 5 factorial. The way to write this when you're writing 2 factorials that are multiplied together, you just write them next to one another. You don't have to write a multiplication symbol. It just means multiply when they're next to one another. So the way to enter this in your calculator would be 69 factorial divided by, since you have an operation going on in the denominator, you need to include parentheses there. 5 factorial 64 factorial. Please do put the commas in once you write those numbers down. I know sometimes it's easier to write it down than add the commas. It's 11,238,513. Anybody get anything different? Okay, parentheses are important. I see a lot of you practicing with me. That's great. The more practice experience you get, the easier it just becomes second nature. Sampling students, then I want you to go ahead and try that one on your own. Go ahead. Combination or permutation? Does order matter here? Doesn't matter. That's the first question you want to ask yourself. So we're talking about a combination then. So combination, and we're talking about junior level course with 42 students enrolled, and we want 5 of them. Raise your hand if you got this far. Sweet. And then we would write that out as 42 factorial. When you divide out all those different ways to write, or to list the students, and then 42 minus 5 factorial. I shouldn't have put that in parentheses, sorry. You don't need those parentheses. So what did you get for your answer when you did that, Garvin?
850,668.
Thanks. Right, and you could have done that using your factorial key, or you could have done that using your, who already is just using the combination key. Or we type in 42, choose 5, and then you get it. I listed out some steps here, just as I think about doing questions like this. The big, like this, probably most common mistake would just be choosing the wrong method. So you want to decide if order matters. Notice when order mattered, we could also use the basic counting rule. It wouldn't work with the combinations. Okay, if we tried listing these out, CDs, 69 to choose from, 68 to choose from, we would wind up with a lot more than 11,238,513. Okay, just a side note. So decide if order matters. Second, rewrite the problem using the combination or permutation notation, and then write out the appropriate equation. Sometimes, and that applies to permutation or combination. Sometimes basic counting rule is the best way, right? When we're talking about things like license plates, we don't need a permutation or combination. We're talking about our different options for an apartment. We would just do the basic counting rule. 4 times 3, 12, done. So there's your lesson on some basic counting, the basic counting rule and combination.